Alright, as you can see here, we have three algebraic terms: 22xy squared, 33y squared, and 55x squared y squared. Now the first thing to note is that I need to kind of split up these terms so that I can find a greatest common factor. Now in a previous video I talked about how to make a list of factors. In this case, for 22 it would be 1, 2, 11, and 22. But then you have the x's and the y's and it gets a little more confusing. So here's what I recommend. Let's go ahead and take the number term part, which is the coefficient, and make a prime factor tree out of it. So we're going to split it apart into its prime factors. So if I look at 22, I'm going to get the right color here. When I use the blue color here and I make a tree, I'm going to start with number 22 and I think what times what makes 22, and that would be 2 times 11. Notice that both of those are prime factors, so I'm going to go ahead and start my list. 2 times 11. Then I look at the variable part and xy squared. The best thing to do is just to split that apart and write it in expanded form. So I'm going to have x times y times y. So that's my term all split apart into its smallest parts. Those are the prime factors. So for the next number, 33y squared, I could make a factor tree, but it's also pretty easy to do it in your head. So what times what makes 33? And make sure that you end up with all prime factors. And 3 times 11 is going to work there. So now I'm going to have y squared represented as y times y. 3 times 11 times y times y. So for 55, it's okay to go ahead and make a tree again. And let's split it up into its prime factors. What times what? 11 times 5. And those both happen to be prime. So let's go ahead and put that in order. Whoops, let's not go with the 2 here. Let's say 5 times 11. And now we'll split it apart into x times x and y times y because of the x squared, y squared. Alright, now the trick is to find the greatest common factor for all of these. So what you're going to have is a vertical circling of anything that's in all three lists at the same time. So I look at the 2, the 3, and the 5, and nope, those are all in their own separate lists, but the 11s are a common factor. So once I circle it, then I write it down and kind of keep track of it. That's going to be part of my answer. Then I look at the variable parts and the x's and the y's, and there isn't a single x in every list, in all three lists, so I can't have any x's in my answer. But then I notice that there's a pair of y's in all three lists. So just to save time, let's go ahead and do those at the same time. So you're going to have a y and another y in your answer. So 11 times y is going to give you 11y squared. Alright, my next set of terms is 56a to the 4th, 28a squared b squared, and 70a squared. So the question again is, what's the greatest common factor of these three algebraic terms? So I need to make a split apart factor list. It's called a prime factor list. And what I'm going to have to do is, if I can't do it in my head, I'll go ahead and make a prime factor tree and break it apart. So 56 is made up of 8 times 7. 7 is prime. Split up 8 into 4 times 2. And my final result is going to be, when I circle all my primes, 2 times 2 times 2 times 7. So now I want to make sure that I'm going to write those in order on my list. 2 times 2 times 2 times 7. And I should be able to multiply those together to get 56. The a to the 4th part is just going to be written in expanded form, and of course that means 4 a's multiplied together. A times a times a times a. Alright, that's my prime factor list for 56 a to the 4th. The next term, 28a squared b squared. let's go ahead and make a tree. And you'll remember that one way to do that is 4 times 7. 7 is prime. 4 is not prime. It is, of course, 2 times 2. So put it in order. 2 times 2 times 7. What do you do with the a squared, b squared? Well, hopefully you've already tried this on paper. Check your results here. A times b times b. Getting a little sloppy with my pen there. All right, now we need to look at 70a squared. And you can be able to get pretty good at this eventually. Instead of making a tree, just think about it. What times what makes 70? 7 times 10. 10 is not prime, but I know that has to be 2 times 5. So 2 times 5 times 7, that'll make 70. And a squared is a times a. So I have all three of these algebraic terms written out in expanded form in prime factors. I'm going to change my color here so I can do some circling. And I'm looking for the greatest common factor. So I noticed that there's a single set of 2's in all 3 rows. Okay, not a pair of 2's, but a single set of 2's. So I'm going to go ahead and circle those, and those will become the first part of my answer. I don't write 3 2's down, I only write a representative 2 to represent that single set of 2's. Then I checked the other factors and I noticed that there's a set of 7's. A single set of 7's. So I write a single 7 as part of my answer list. Then we look at the variables, the a's and the b's. So the question is, what's the largest group of a's that's common to every list? Okay, I have 4 in the first row, 2 in the second row, 2 in the third row. So 2 is the largest group of a's. A pair of a's is going to be part of my greatest common factor answer. And then of course I check to see what's left. I notice the 2 b's in the middle row, but there are no other b's that are in common. Okay, so again, you're looking for the largest group of each letter variable factor. So now we're going to put this all back together again, and this will give us our answer. It'll be 14a squared. All right, very good.